Hello and welcome to the next lesson. So in the previous lesson we did set up here our simple velocity creation or velocity simulation and then cached it out. What I want to do now, let's go just to the original range, so 1 to 240. And I will just drag and drop our vellum, little vellum system down here. For example, what you need to get now is like the scale right. So if you have a look on our basically on our velocities and then have a look on our piece of fabric. For example, what I would do in this scenario, I will just rotate the piece of fabric. So just try to look a little bit into the scale. Another thing I want to talk about is like to create here different setups. For example, another cool velocity setup would be just make a straight one, so that will go straight upwards. So just make a simple constant. So constant as a free float vector into the velocity and x, y, z into the y action into the y axis. Just type 1, and you now got basically like a simulation that will get straight up. Let's just get that one here. So for example something like that, and when you have a look at the velocities, so let's just cache that out a little bit, you will see that it will basically get straight up. So let's reload them. But I think that's also cool for vellum simulation, especially when you place the piece of fabric like not directly on top of it, like a little bit separated to the side. But of course we can do that now. So the initial velocities, we will then feed them in. I will do it just onto the fourth input. And let's just hit here simulate, and of course the wind is in there, pop wind. Let's disable that with Q. And what I want to do, I will want just a quick representation. Oh no, don't simulate the vellum from our velocities, and then transform a little bit our piece of fabric. For example, something like that. And of course you can then play around with the direction, with the rotation, with the scale. Another thing that we will do is like to copy them on top of each other, because you will get like a lot more details that will look pretty cool. So now what we will do, let's dive inside our .NET. So basically let's just rename that to vellum sim. We'll dive inside, and what we will do is place down pop at vect by volumes. Pop it by volumes, feed that into the particle forces, and we'll use the fourth context geometry, so velocity source, fourth context geometry. I will use update velocity, and then you can, for example, influence the velocity scale. So let's just have a look here on our first simple iteration, and you already can see we will get a cool amount of of organic movement here just with the simple upward movement. So I think basically that setup with the simple upward movement is pretty nice to reveal something. So you can use it for that, for example, to reveal maybe a product or something else. And then you can play with the velocity scale, of course. and you will get the real juice. Of course, now if you have a look on that and you can basically see it, it looks pretty shitty, like with this kind of subdivision level. That's because we did place the vellum post process down, and you can already see it will do a much better job here. Another thing what you can do, of course, you can get like a really high res simulation and get the edge length on another level, like 0.025 or a little bit lower, but I think that's like a good start. Another thing that I want to talk about, what we will do now, let's just get one more type of simulation, because we now created like this only upward movement, but I want to create, of course, the little bit more chaotic movement too. So that was that one here. Yeah, okay. What I want to do on that one, let's just play a little bit with the offset here of the curl noise. Maybe like that. Okay. So you can play around with the offset, and you will get quickly other smoke iteration. Cool, so we can cache that out here. And for like the most of the part, I think you can play with the velocities. So like different geometry inputs, so you can use, for example, like a really long geometry input to create like a velocity wall, and then advect a really long piece of fabric, for example. And what also is pretty cool, if you then get multiple simulations running, for example one with upward movement and other simulation with downward movement. Of course you can just copy them, for example, and rotate them when you cached them out. So I think that's also pretty cool to do. So let's just cache it out, 5 more frames, 3, 2, 1, 0, liftoff. Cool, so we cached it out. Let's have a look here. Okay, that's pretty massive. Let's have a look on the volume trail, because I think the volume trail is also really cool to look at. Let's just get more points. Yeah, looks pretty cool. Nice. So that will be our sim here, and if you visualize the velocities, you can also see them on your piece of fabric, and you can see how it will advect your fabric basically. So what I want to do now, we got like this, let's just reload that, we got like this upward movement, and what I want to do here is like create multiple sheets of fabric. So let's just get a resolution a little bit lower here on that piece, and I will use a copy and transform. Copy and transform. And then we can just get multiple pieces or multiple layers of fabric. So for example 5 layers. And with the 5 layers we can then of course change, for example, the rotation and the translation. I will move them a little bit upwards, and let's have a look. Yeah, you will get basically something like that. Okay. Let's simulate that a little bit longer. And of course, for the final iteration, you can set up your or you will need to set up your substeps and maybe the layer shock and the collision passes to get a much more representation of your vellum fabric. But it looks pretty good for the first type of main iteration. And you will get, like, with the layers, you will get like pretty cool intricate details here. So let's type another kind of simulation. Of course you can always skip that and jump directly to the rendering part. But yeah, let's try some others out too. For example, let's copy that again and let's have a look on the velocities here. Okay. Let's go with the frequency up here. Something like that. And of course you can play with the amplitude. Cool noise again. But let's get the amplitude. Let's get it maybe higher, and I will just normalize that. And let's simulate that and see how the velocities will look on that one. Reset simulation. Yeah, of course, because of the normalization, you will get a whole other level of, yeah, basically distribution. So when you deactivate that and just reset it, you can clearly see the change in the velocities. Okay, but I think that's good for now. So, or maybe let's do one more. We can, of course, always do more. Let's get a simple one with I will just kill the frequency here, so maybe make the frequency lower, and I will dial down the roughness a little bit. The call noise, let's just disable the add one here. And for visualization, just pipe that quickly into our velocity. Get the roughness up here, something like that maybe. Okay, and then again add here. Let's just visualize the velocities from the call noise here. I will do a fit range on here too. Should just get a little bit of a other kind of movement. And the fit is pretty cool because you can really like quickly direct your velocities. And add on here. Yeah, let's have a look how that will turn out. That one here. Okay, let's reset the simulation. And of course, let's just make one more thing, the time aspect. So we didn't include now our time aspect. Of course, we can do that. So vector to vector 4. Pipe that in here, and in here. And we will use the time, of course, the time and a multiply constant. Pipe that in here. And when you look it's at the current state, it's pretty fast, but let's make it slower. So for example 0.2, let's make 0.125. Yeah, I think that's good. Okay, now let's simulate that. And you can already see the influencing time aspect here. That's good. Yeah, okay, cool. so we can use that for simulation. Another thing what I want to do, I will scale the time a little bit, so I will just make it a little bit slower, because why not? Let's reset it, and then we can cache it out. And of course, you can try that out with the time scale, especially with like slow motion or speed ramping. So you got like time scale 1, 0.1, so from fast motion into slow motion, and then you can try to, or you can do an experiment with, like, you got your vellum solver, and you can try out to influence the time scale on there and on your DOP network for the velocity simulation, or you can try it out only, for example, on your vellum simulation or on your velocity simulation. So let's have a look on that. Let's at first look how they will. Oh, that looks pretty cool. Let's just get the velocity trail here. I want to look at it. Oh, that's massive. Okay, cool. Nice. Looks like a tree a little bit. Let's reset it and have a look. So we will get so let's do one thing. What I want to do, I will just rotate them a little bit, and that's also a good thing to do. Just rotate a little bit them, and then rotate them in their copy and transform to get maybe something like that here. So they will be closer together here and farther split out on that side. So you can just really try to get creative with your initial simulation state. Of course, what you also can do, you can involve like the vellum brush and firstly sculpt your vellum form to your like, and then you can simulate it. So of course that's again fully up to you. Okay, I think we need to get a little bit more power in here. Let's just move it down, and I will go back on here. And let's check. I will just check the okay, already at 5. Yeah, I will just go back to the time scale, and I will make it not so high resolutional. 0.075 should be fine. Let's just cache that out again. And of course, what you can do, you can save like different velocity iterations to play with them. So you can do one like slow motion, one like normal, that kind of inherited velocity and that kind of inherited velocity, and then apply that to different pieces of fabric. So let's wait till that is cached out too, but that will be really fairly quickly done. So we can just reload that again. Let's have a look. Okay, that's much better. So of course with the slow motion you can try that out, of course. So we'll get a cool movement here, but what I want to do, let's just rotate it, for example. And for that one, I'll just get me the green one, move that up, and maybe just rotate them a little bit. So again, fully up to you. Yeah, that's much better. And let's have a look. Yeah, that looks nice. Yeah, okay. So, for example, now in that kind of iteration, you will, I think you already got like a good idea how you can render that. So you will get like a really cool detail shot here, maybe an overall shot like that one here. I think that looks really cool with this kind of bending here and then again here, and with this sort of splitting up here. So yeah, I think that iteration is good for getting it in to the rendering lesson, or the final lesson basically. And what I will do, I will dive inside the dub network and I will just get the layer shock a little bit higher, so maybe 5 or 6. The sub steps, I will get them to 2 or 3, just maybe 2 for the first step. Constraint iteration, maybe, so you can try it out, and collision passes I will get them to maybe 20, and then I will resimulate that. Another thing, of course, what you can do, get to the planar patch, and I will dial down the resolution, so for example 0.035, and then I will resim that again, and I will see you in the next lesson, or the final lesson of this course, with rendering and look development, shading and so on. Okay, I will see you.